Hello everyone, this lesson is on finding the surface area of composite solids. So the first important thing to know about composite solids is it just means we're taking two or more three-dimensional shapes and connecting them, attaching them. So you can see in my picture here, I have two three-dimensional shapes attached. So this is one composite solid now. So I'm going to look at the left side first. I'm going to use my highlighter just to highlight the shape I'm talking about here. So this left side here, every side of this three-dimensional shape is a rectangle. So that makes this a rectangular prism. So let me clear that off. Now let's look at the right side of our composite solid. I can clearly see a right triangle in the front and the same right triangle in the back. And these two right triangles are connected in between by a bunch of rectangles. That makes this a triangular prism. So I have a rectangular prism and a triangular prism connected to make one composite solid. Now, here's another really important key idea about composite solids, and here's how I like to think about it. Anytime somebody asks me to find the surface area of a composite solid, the first thing I picture in my head is, okay, what if I have to paint this? And if this is a solid shape, you don't put paint inside. You can't put paint inside. So see this rectangle right here, and I'm using my pen to outline it. This rectangle right here in the middle, that's where our two prisms are connected. So if I had to paint this solid object, this rectangle is never getting any paint. It's inside of a solid shape. It's not getting painted. So I have to keep that in mind when I start doing my calculations. So I'm going to start first with the top of the box. I'm going to refer to my rectangular prism as a box. It's just quicker. The top of this box is 12 long, but how wide is it? There's no number over here. So what I have to do is I have to travel across to the other side to see this is 10 centimeters. So if that's 10 centimeters, so is this, and so is that. So I fill in the 10. Now let's find the area of the top of our box. Area of any rectangle we know is length times width, right? And we just said the length of the top of our box is 10. 12. The width is 10. We multiply those two together and we get 120 squared centimeters. But what do we know about a box? Well, if the top of the box is 120, doesn't the bottom of any box, it's the same as the top. So I'm not going to show you the math again. We know the bottom matches the top. So I'm just going to rewrite 120 centimeters squared or squared centimeters for the bottom. So I have the top and I have the bottom. Now let's take a look at a different side. I'm going to switch colors. I'm going to talk about the front of this box. The front of the box I can see is 8 high, 8 centimeters high. And again, 12 I get from the other side. So this is 12. So the area, length times width, of the front of this box is 12 times the 8. And we get 96 squared centimeters. Well, the front of the box is getting paint, but the back of the box, we can also paint that surface. And the back is always the same as the front, right? So let's just put in another 96 squared centimeters. All right, so I'm going to change colors one more time. Now, this far left side, I'm going to outline it. Well, that's terrible. Let me back up. Let me try that again. I'm going to outline it in green. This left side is 10 by 8. So it's one more rectangle. But remember, even though the right side matches the left, we're not painting the right. It's inside the box. So I only have to do one more. I have to do 10 times the 8 centimeters, and we get 80 centimeters. And then I got to add down centimeters squared. And when we add down 120 plus 120 plus 96, 96 and 80, and we get 512 squared centimeters. So we're done with our rectangular prism. Okay, now let's come over to the opposite side, and now let's start focusing on our triangular prism. First, I'm going to put the formula for area of a triangle. Area equals 1/2 base times height, right? 1/2 times base times height. Now, let's start with the triangle in the front. And once again, I'm going to outline it with my blue pen. And we can see the base is 15. So I have 1/2 times the base, 15, times the height, same as over here, 8 centimeters, 8 centimeters, times the 8. And I get 60 squared centimeters. Sorry, my pen is giving up on me here. Bear with me. All right, so our front triangle is 60 squared centimeters, but so is our back triangle, right? So I'm not going to show you the math again. The back matches the front. So we got another 60 squared centimeters. Okay, remember, This triangle inside here, that's not getting paint, so we can ignore that one. Now I'm going to get my red pen again, and we're going to look at the bottom of this prism. 15 long and 10 wide, right? It's just a rectangle. So we already know the formula for rectangle is length times width, so let's just get to it. Length times width, or 15 times 10, equals 150 squared centimeters. Now I'm going to change colors one more time. The only other rectangle we still need to worry about is the top of this triangular prism, right? 17 by 10. And once again, it's a rectangle, so I'm going to get right to it. 17 times 10, and we get 170 squared centimeters. That's it. We have all of our surfaces. So I'm going to draw my line, and we're going to add down, right? We have 60 plus 60 is 120, plus another 150 makes 270, plus another 170 makes 440 squared centimeters. So our last step, I'm going to change my ink back to blue, one of my favorite colors. Our last step, we have all of our surfaces, and we added up the ones that are getting painted on the rectangular prisms and the ones that are getting painted on the triangular prism. So let's just add those numbers. We got 512 centimeters squared plus 440 centimeters squared, which gives us a total of 952 squared centimeters worth of paint if I had to paint this item. And ladies and gentlemen, that's the end of this lesson.